Good morning, guys. I am Reginald J. L. Argamosa, or Reggie for short. So today I will be presenting my work as part of my task as a machine learning specialist in Project GUHeat titled Creating a High-Resolution Land Surface Temperature Maps Using Machine Learning. So this is the outline of my presentation. But first, let's discuss what is spatial resolution. So in simple terms, a resolution is the fineness of the patterns on an image or the detail an image holds. The resolution is often considered equivalent to pixel size. Pixel is the smallest portion of an image. Spatial resolution, on the other hand, is usually reported as the length of one side of a single pixel. For example, this is a Landsat 8 image. This Landsat 8 has 30-meter spatial resolution. In other words, an image with a 30-meter spatial resolution means that a single pixel represents an area on the ground that is 30 meters across. So if you have smaller pixels in an image, the data will appear more detailed. However, if you have large pixels, such as the 30-meter resolution, the data will appear more coarse or fuzzy. Another example showing different resolution sizes. A high spatial resolution is required when, for example, determining separate houses. This is the classification of different pixel resolution sizes based on what scale of the application it is usually used. Say if you have a 1 kilometer to 10 kilometer resolution image, that image is best used for international coverage and so on. Example of low resolution images are those coming from weather satellites. Example of medium resolution images used in analyzing the variabilities of the Philippine vegetation cover. A high resolution image used to assess the Baguio City. A very high resolution image showing richer details of a city. So why is there a need for a high resolution image of LST? Landsat 8 has two sensors on board. The OLI, which has a 30-meter resolution, and the TIRS or the thermal sensor, which is a 100-meter resolution. In fact, the TIRS sensor is the only functioning spaceborne sensor that has the highest resolution as of now. The 100-meter is upsampled to match the 30-meter OLI. Now, why don't we just upscale the 100-meter resolution? Upscaling doesn't really give more detail about the image. It will just occupy more disk space because of the increase in pixel number. What we need is to create a data straight from the original resolution. On the, on the other hand, technologies such as the thermal cameras mounted on drones are expensive, and their area coverage is only limited. Also, data cannot be gathered quickly, unlike when using satellite images. This part here is where we develop our machine learning model. This is what a 100-meter land surface temperature looks like. When we applied some overlay techniques, this is what it looks like. We can notice that few information are contained in this LST map. Shown by the arrows are the generalized surface temperature values, or notice that the colors of the LST has poor correlation with the details of the area. The details, meaning the objects in the city like the trees, houses, bare areas, etc. If we have a higher resolution LST map, there can be a more effective planning when it comes to mitigating the urban heat island effects. Next, we discuss what is machine learning. We humans learn from past experiences. Machines, on the other hand, follow instructions given by humans. But what if humans can train the machines to learn from past data? This is what machine learning is all about. In order for us to understand machine learning, we discuss the basics. Say this is you, and you want to listen to new music. You will like the music based on the tempo and intensity. So if you have this X and Y axis, and on your X axis you have the tempo, which ranges from relaxed to fast. And on the Y axis you have the intensity, which ranges from light to soaring. So if we have this data, we can create a decision boundary based on the like songs and dislike songs. So if we have a new song that has a fast tempo and soaring intensity, we know that based on the new characteristics, it will be classified as a new song. However, if we have this new song that has medium tempo and intensity, the problem becomes more complicated. But when we draw a circle around the point, we can notice that three like songs were included, while there are two dislike songs are included. So by a majority vote, it is more likely that the new song will be classified as like songs. What we actually did is a simple machine learning algorithm called the uh, k nearest neighbors. Now, machine learning model learns from past data, and it builds a prediction model and will in turn project the new data. Machine learning is a type of artificial intelligence or AI. It looks for patterns and it can adjust itself to make more accurate predictions. And it can teach themselves to grow and change. Machine learning is about learning to do better in the future based on what was experienced in the past. Facebook newsfeed uses machine learning to personalize each member's feed. If a member frequently stops scrolling in order to read or like a particular friend's post, the newsfeed will start to show more of that friend's activity earlier in the feed. Behind the scenes, the software is simply using statistical analysis and predictive analytics to identify patterns in the user's data and use the patterns to populate the newsfeed. Should the member no longer stop to read, like, or comment on the friend's post, the new data will be included in the data set and the newsfeed will adjust accordingly. So now for the objectives of this study, the objective is to teach a machine learning model to learn the relationship between the input data and the lower resolution LST data. Once learned, the machine learning model will predict LST values using the learned relationship to high resolution images. Next, we discuss the two satellite imagery that we use. The first one is the Landsat data that contains the visible and infrared bands, which is a 30-meter resolution image. It also carries the thermal sensor that produces the 100-meter thermal band. Next is the Sentinel-2, which produces bands that has resolution of 10 meters. Next, we discuss how we build the machine learning model to learn from the data. First things first, let's define two important terms, the features and the targets. Features are the input in the system and serves as the building blocks of datasets. Targets, on the other hand, is the output of the input variables. It is the dataset about which we want to gain a deeper understanding. In our case, the features are the high resolution satellite images. Then we will build a model that learns the relationship of the features to the targets. On the process, we will create an intelligent model that already learns the data that we fed into. Next is we did feature engineering, or the process of using the domain knowledge of the data to create features that makes machine learning algorithms work properly. This involves the creation of new features, and the quality of the features in our dataset has major impact on the quality of the insights that we will get. Next, we improve the quality of our dataset's features by doing feature selection to make sure that important features are optimal. The total number of features were reduced to 34. So this is an example of a feature that was found out to be important and contributes to the best performance of the model. This shows that darker green areas are more covered with vegetation, such as trees, shrubs, grass, etc. On the other hand, this is the urban index, another important feature. This shows that the darker violet corresponds to high density of built-up structures. Now, from the 34 features, we did algorithm selection. Not all machine learning algorithms are created the same. Some algorithm works well on specific problems, but some are not. Hence, we did the algorithm selection process, where we tested lots of machine learning algorithms spanning from penalized linear regression, bagging and boosting algorithms, as well as artificial neural networks, to come up with the best algorithm that will be used in estimating LST. From the final algorithm, we tuned the hyperparameters. Hyperparameter tuning is the process of choosing a set of optimal parameters or the settings of the algorithm, whose value is used to control the learning process. Tuning the hyperparameters will make our model intelligent. And finally, we assess the results. So now we assess the performance of the machine learning model. So this is the result or the performance of our machine learning model shown by the scatter plot. On the x-axis is the LST values predicted by our machine learning model. On the y-axis is where the resolution LST is where the lower resolution LST values. The R here shows the R here or the correlation coefficient shows the strong correlation between the predicted values by our model and the lower resolution LST. R squared, on the other hand, is the coefficient of determination, which means that 56% of the outcome is explained by the model. There are no perfect model. Error is always present and the goal is to lower it as much as possible. If we use our model, we can expect that the error is more or less plus or minus 1.13 degrees Celsius, and the percent error of our model is only 2.84%. And finally, let us look at the results. This is the vegetation and built-up index shown in one map. Now, this is our 100-meter spatial resolution LST map. This is our 30-meter, and this is our 10-meter. And be zoomed in, and what I'm showing you right now is the vegetation in built-up index for reference. This is your 100-meter spatial resolution LST map, the 30-meter, and the 10-meter. We scaled it up to the whole Quezon City and also in Baguio. And lastly, in the whole Metro Manila. So in conclusion, we were able to create a tuned machine learning model for estimating LST. The model achieved relatively low error, and we were able to apply the model to higher resolution images such as the Sentinel-2. Higher resolution LST map can help the decision makers in making appropriate approach in mitigating the UHI effects. So thank you. So that's all.